Hello everyone, welcome back. Today we are going to dive into a fascinating topic in data structure and algorithm, detecting loops in a linked list using Floyd cycle finding algorithm. Before we get into the details, let's quickly revive what a linked list is. A linked list is a data structure where elements called nodes are connected to each other. But what happens when a node points back to a previous node, creating a loop? This introduces an interesting problem. How do we detect if a loop exists in a linked list? That's where Floyd cycle finding algorithm comes into play. Floyd algorithm is an efficient way to detect loops in a linked list. It works by using two pointers, a slow pointer and a fast pointer. The slow pointer moves one node at a time, while the fast pointer moves two nodes at a time. The key insight is that if there is a loop, the fast pointer will eventually catch up to the slow pointer. If there is no loop, the fast pointer will reach to the end of the list. We will understand the algorithm now first, and then we will write program for this. Uh, our recording is going on. First of here is the example of a linked list. This is a node, first node, second node, third node, and we are seeing that the last node is not pointing to null. It is pointing to the third node, and the third node again fourth and fifth, and this is creating a loop. If we will print this, and it will going to print, and infinite loop will be run and not stop it. To find this in our linked list, if we want to find this, how we will find this? First of all, here is the algorithm we will show here. First of all, we are using a slow pointer and a fast pointer. Two pointer are we using, a slow pointer and a fast pointer. Here we are saying that 10 is the head of this linked list, and a slow pointer and fast pointer both are pointing to this node. And now the fast pointer moves fast and the second pointer moves slow. Here in the next step, we are seeing that the slow pointer moves one step ahead and the fast pointer moves two step ahead. The fast pointer points to the element 4, and next it will point to the element 10. And the logic behind this is that if loop is in our content in our list, and then once at a time slow pointer and the fast pointer is points equally. For example, here is the fast pointer is at 10 and the slow pointer is at 4. Again the fast pointer is at 4 and the slow pointer is at 20, and in next iteration the fast pointer point to the element 10, and also the slow pointers point to the element 10. We can see that we both are started from here and we reach here, and then we will say that loop is detected in our linked list. This is the logic, and we have to create program on it. And we will now go to the VS Code and our code editor, and we will write program for it and sing logic by logic. First of all, we will use our boiler pointer to create a basic syntax, and now we will move ahead. First of all, we will write our main function after the declaring struct node. First of all, here is the struct node we will write. We will is integer type for our data. Sorry, data, and self-structing node we will create to the next, and semicolon after it. Now now we will create head, second, sorry, third, and our last element is fourth. We will take this for our example, and now we will be allocating memory for it. First is head and second is, sorry, second, third, and fourth. uh, By using malloc, we will dynamically allocate memory for this using size of, and this will be again struct node. Here you can say that see that first of all head को हम null कर देंगे, और अगेन यहाँ पे हमारा मेमोरी allocate हो चुका है, and we will now allocate data for it, and also we will point this data is equal to let 10, and head points to its next, sorry, to second. It will to the third, it points to the third, and here is equal to, and the fourth data will be let 40, and our fourth is the last node since it will represent the null. Here our singly linked list are created with 4 nodes. First one is head, second, third and fourth, and we will dynamically allocate memory for it using malloc function, and data are 10, 20, 30, 40, and the first one is representing second, pointing second, and second one third, and third one fourth, and fourth one again null, and now here our singly linked list are end. But what happen if we write here second or third? What happen if we fourth node uh, points to the second or third node? Let us we write here second, then this is a we are seeing that this is the loop in our singly linked list, and now we have to write a function for to find it. We will write a function with name detect loop, and its return type is int, since it is returning 1 or 0 as per the value. So we are writing here detect loop function, and the input is same, the head of our now here we will use tortoise and हेयर। जैसे बचपन से हम लोग कछुए और खरगोश की कहानी सुनते हुए आ रहे हैं, तो हम उसी का यूज़ करेंगे यहाँ पे। कछुआ धीरे दौड़ेगा और खरगोश तेज दौड़ेगा, और शुरू में ये दोनों पॉइंट कर रहे होंगे हेड को, तो ये हमने इतना कर लिया। और इसके बाद से अब विल यूज व्हाइल लूप व्हेन हेयर इज नॉट इक्वल टू नल, and here next is also not equal to null, and we will nothing write in this while loop, only both कछुआ और खरगोश सिर्फ दौड़ेंगे। तो यहाँ पे कछुआ धीरे दौड़ेगा, तो कछुआ को हम लोग धीरे दौड़ाएंगे, and tortoise implies next, and here is equal to here, We will write now the according to the algorithm, if hair is equal to tortoise, then loop exists, and we will return 1 for it, and outside uh, again outside, while if hair is not equal to tortoise, then return 0. Here is our function of detect loop, and now we will use this function in our program to check this it is correct or not. Here we will use if statement and detect loop, and we will pass head of our linked list, and we will print here that loop is detected in our list, and else we will print that no loop is detected. And now we will run this program and see an error come or not. First of this struct note, यहीं पे गलती है, कह रहे थे कहाँ पे गलती now. First of here we will run our program, and we will see that loop is detected in our linked list, uh, as we will create our linked list, and now we will change the second to null, and now fourth node is points to the null, so there is no loop. Now again we will run our program and see there is no loop is detected, so our program is complete, and now we will close this is the Floyd cycle finding algorithm. uh, we can easily detect loop in our linked list. Now as you can see, the algorithm correctly detects the loop. You can try this with different linked list to explore further, and there you have it. We have explored Floyd cycle finding algorithm for detecting loops in a linked list using C. I hope this video was helpful in understanding the concept and implementing the algorithm. If you enjoyed this video, don't forget to like, share, and subscribe for more content. And happy coding, and I will see you in the next video.